Good evening. See, let us continue with PYQs from JE main. From the topic motion in a straight line. See, actually, in the previous session, we have completed 24 problems. Let me begin with 24th problem again. A particle initially at rest starts moving from the reference point x is equal to 0 along x-axis with a velocity v that varies with distance as v is equal to 4 root x. Find the acceleration. See here, if you just recall the equations of motion relating velocity and displacement, v square minus u square is equal to 2as. See here, u is the initial velocity, a is a uniform acceleration. In this example, it is given as v is equal to 4 root x. Squaring on both sides, v square is equal to 16x. So if you compare this equation with v square minus u square is 2as, in this problem, the body started from rest, u0. So if you compare these two, displacement here is expressed as x here. So v square is 16x. If you compare this, v square is equal to 2a in place of s. If you take x, see here, 2a is equal to 16, which implies acceleration is 8 meter per second square. So the answer for that is 8. Right? Now, look into this problem. We have done the same kind of problem several times already in PYQs. See here, let us look into 25th problem. A particle is moving along x-axis under the action of variable force. Initial position is 16 meters right of the origin. Suppose if this is 16, this is the origin. Initially, it is 16 meters right of the origin. The variation of its position with respect to time is minus 3t cube plus 18t square plus 16t. That is, with respect to the origin, this is the equation. Velocity of the particle when its acceleration becomes equal to 0. Actually, this has no relevance to the question. Okay, so we are just ignoring. If you have displacement as a variable function of time, how do we get velocity? By differentiating displacement with respect to time, we get velocity. So here, velocity is equal to minus 3 t cube derivative is 3t square plus 18 t square derivative is 2t plus 16 t derivative is 1. So from that expression, velocity is equal to minus 9t square minus 9t square plus 36t plus 36t plus 16 plus 16. So acceleration by differentiating velocity with respect to time, we get acceleration. So minus t derivative of t square is 2t plus 36. So what is asked in the problem? Find its velocity when its acceleration is 0. So acceleration is 0 implies 0 is equal to 18t plus 36, from which 18t is 36 implies t is equal to 2 seconds. Right? Now, you are supposed to find velocity at the instant time is acceleration is 0. Acceleration is 0 at 2 seconds. So substitute 2 in place of t here in the expression for velocity. So v is equal to minus 9, 2 square is 4 plus 36 into 2 plus 16. So this is minus 36 plus 36 into 2 plus 16. 36 plus 16, 36 plus 16, it will be 52 meter per second. So the answer is 52 meters per second. Okay. So let us move on to the next problem. Look here. A car covers AB distance with first one third with V1, second one third with V2, third one third with V3. Find the average velocity of the car. See here, we know the direct formula. If a body covers one third distance with V1, next one third distance with V2, next one third distance with V3, then average speed is how much? 3 V1 V2 V3 by V1 V2 plus V2 V3 plus V3 V2. So here the formula is 3 V1 V2 V3 by V1 V2 plus V2 V3 plus V3 V1. Here it is given V3 is 3 V1, V2 is 2 V1. So if you substitute that 3 V1, V2 is 2 V1, V3 is 3 V1 by V1, V2 is 2 V1 plus V2 is 2 V1, V3 is 3 V1 plus 3 V1 into V1. So here actually V1 square gets cancelled. 3 2s are 6, 6 3s are 18. 18 V1 by 2 plus 2 3s are 6 plus 3 1s are 3. So this is 18 V1 by 11. So that is the average speed. What is the value of V1 given here? It is given as 11. So if V1 is taken as 11, this and this gets cancelled. Average speed is equal to 18 meter per second. So the answer is 18 meter per second. This is the formula. Definitely you have to remember. Okay. So if you remember the formula, you can solve this simple formula straight away, problem straight away. Then you can save time and you can spend that time on difficult problems in the same question pattern. That's how you'll be able to manage time in the examination. So looking into 27th problem. Look here. 27th problem. Look. Velocity of a body related to displacement x is given by v is equal to square root of 500 plus 24x. Then what is its acceleration? Once again, what equation of motion connects velocity and displacement if acceleration is uniform? Yes, v square minus u square is equal to 2as. Now, let us square this equation. V square is equal to 500 plus 24x. V square minus 500 is equal to 24x. Let us, as this is in this form, let us compare this with this equation. So on comparison, u square is 500, 2a is 24. 2a is 24. A is equal to 12 meter per second square. So acceleration is 12 meter per second square. If you are asked to find the initial velocity, u is equal to root of 500 or 10 root 5 meter per second. From that, the problem can be extended. to any length. So U is known, A is known, you may be asked to find anything based on equations of motion. So first we have to see whether that is moving with uniform acceleration or not. Well, we are able to compare the given equation with the standard equations of motion. If you can do that, problem is simple. Otherwise, you have to go for integration method. Okay. Now, let us go to the next problem, 28th problem. Look here. Let us go to 28th problem. A ball is thrown vertically up with an initial velocity. Look here. 150 meter per second. Ratio of its velocity after 3 seconds, after 5 seconds is x plus 1 by x. Value of x is. See, read the problem carefully first. Okay. So, a bar thrown vertically with an initial velocity. I'm talking about 28th question. Initial velocity of the ball is 150 meter per second. It is thrown vertically up. Ratio of velocity after 3 seconds, after 5 seconds. In case of vertical projection, A is equal to minus G. Value of G is given as 10 meter per second square. When t is equal to 3 seconds, what is the velocity? What equation connects them? V is equal to U plus AT. So, velocity at the end of 3 seconds becomes 150 minus 10 into 3. That is 120 meter per second. Similarly, velocity at the end of 5 seconds is 150 minus 10 into 5, 50. So 150 minus 50 is 100 meter per second. What is given here? That ratio is given as V1 by V2 is given as x plus 1 by x, implies 120 by 100 is given as x plus 1 by x. So 5, 6. So 6 by 5 is equal to x plus 1 by x. Actually, by applying cross multiplication, you can do that. But from the trial solution, you can tell. If x is equal to 5, x plus 1 is 6. So very obviously, x is equal to 5. That is the answer. So find the value of x. The value of x is equal to 5 in that problem. Is it okay? Let us move on to the next problem. Look here. A juggler throws balls vertically up with some same initial velocity in it. When the first ball reaches its highest position, he throws the next ball. Assuming the juggler throws n balls per second, the maximum height of the ball. So the juggler is throwing the balls vertically up at regular time intervals, right? And he is throwing n balls per second. So the time gap between actually by the time the first ball reaches the maximum height, second ball is about to throw. Meaning the time of ascent is 1 by n here. Number of balls thrown per second is n. So, time taken by each ball to reach the maximum height is 1 by n seconds. So, what is the maximum height? If time of ascent is 1 by n seconds, time of descent is also 1 by n seconds. Time taken by the body to reach from the top to the bottom is 1 by n seconds. In case of freely falling body, maximum height from which it is dropped is h is half gt square. Here t is 1 by n. So maximum height is g by 2n square. That is the answer. G by 2n square. Okay, that's it. Now, going to the next problem, 30th problem. When a ball is dropped into a lake from a height 4.9 meters above the water level. A ball is dropped into a lake from a height 4.9 meters above the water level. It hits the water with a velocity v and then sinks to the bottom with a constant velocity v. Reaches the bottom of the lake 4 seconds after it is dropped. Approximate depth of the lake. So here we need to just understand the question here. See, here this is the lake. Ball is dropped from a height 4.9 meters. So it strikes the water with a velocity v. And then onwards it is moving with a velocity v. And finally it reaches the bottom of the lake 4 seconds after it is dropped. Then what is the approximate depth? So here let us take this distance as S1. This distance as S2. So S1 is equal to 4.9. What is the velocity? V is equal to square root of 2 GH. So velocity is equal to 9.8 meter per second. Velocity with which that ball strikes that water surface is 9.8 meter per second. And the time of free fall, square root of 2h by g. 2 into 4.9 by 9.8. So time of free fall is 1 second. Or time for this journey is 1 second. So for this journey, the remaining time it has taken is 3 seconds. So let us name this as A, this as B, this as C. B to C is the travel in water from top to the bottom. So you have to find that. So here velocity is 9.8 meter per second. Acceleration is 0 and time taken is 3 seconds. S is just V into T because A is 0. 9.8 into 3, it is 29.4 meters. So the depth of the lake is 29.4 meters. That is the answer. Is it okay? Now, let us move on to the next problem. A scooter, 34th problem. A scooter accelerates from rest for time t1 at a constant acceleration a1, then retards at a constant acceleration and comes to rest. Again, it comes to rest. Just if you draw velocity time graph, it will be like this. T, and this is velocity starting from rest, acquires a maximum velocity v, and again it uniformly retards and comes to stop. So here, from this acceleration graph, velocity is a1 t1. From this retardation graph, the same velocity is a2 t2. Implies a1 t1 is equal to a2 t2. What is asked in the problem? T1 by t2, that is equal to a2 by a1. That is the answer. So option B is the correct answer for that problem. Okay. Let's move on to the next problem. Look here. A particle moves along its axis, has displacement varying with time according to the equation. So first you write the equation given there. It is C naught t square minus 2 plus C t minus 2 whole square. Now, where C naught and C are constants with the appropriate dimensions, then which of the following statements is true? So while answering the statement questions, you have to be a bit smarter. You shouldn't waste too much time. See, if you just have a look at the options, in three options here that you mentioned about acceleration. So we need to find acceleration from the displacement equation. So if you want to find acceleration from the displacement, we need to differentiate displacement twice with respect to time. So here, if you differentiate this once with respect to time, this is C naught. T square derivative is 2t. T minus 2 whole square is t square plus 4 minus 4t. So if you differentiate this, t square derivative is 2t. Its derivative is 0 minus 4. So this is velocity expression. So here it is given velocity is 4c. If you substitute t as 0, you are getting velocity as minus 4c. So this option is wrong. So we have to go for acceleration. Just differentiate this with respect to time. So it is 2c naught plus 2c. Its derivative is 0. Our acceleration is 2 into c naught plus c. See here, exactly. The second option is that acceleration of the particle is 2 into c plus c naught. That's what we got there. So that is the correct option. Now, coming to the second question. Two cars are traveling towards each other at a speed of 20 meter per second. So here, if you look at question number 33, two cars are traveling towards each other when they are separated by a distance 300 meters. Both the drivers apply brakes and the cars retard at the rate of 2 meter per second square distance between them. See here, if you consider the first car, its initial velocity is u is equal to 20 meter per second. Retardation is minus 2 meter per second square. Before it stops, what is the distance traveled by it? So this distance we are going to find. As v square minus u square is 2as here, as final velocity is 0, 20 into 20 is equal to 2 into a into s1. That is the distance traveled by the first car before it stops. So here it becomes s1 is equal to 10 and 10, it is 100 meters. Similarly, as the second car is also traveling with the same velocity and brakes are applied with the same retardation, if this distance covered is 100 meters before it stops, distance covered by this car also becomes 100 meters. S2 is also 100 meters. So both cars together has complete 200 meters out of 300. So distance between them when they come to rest is 300 minus 200, that is 100 meters is the correct answer for that problem. Is it all? That is 33. Now look into question number 34. 34. Look here. A body starts from rest, moves with constant acceleration, because we know we can apply equations of motion when acceleration is uniform or constant. So constant acceleration covers displacement S1 in the first p minus 1 seconds, meaning S1 is equal to ut plus half at square. As it starts from rest, u is 0. It is simply half a t square, p minus 1 whole square. Similarly, it covers a distance S2 in first p seconds. S2 is equal to half a into p square. The displacement S1 plus S2 is made in what time? So if you add these two, S1 plus S2 is equal to, if you take that half A as common factor, it is P minus 1 whole square plus P square. So S1 plus S2 is equal to half A, if you P square minus 2P plus 1 plus P square. This is half A P 2P square plus P square minus 2P plus 1. This is S1 plus S2. If you compare this equation with S is equal to half A T square, in place of T square you have that. So the time taken is square root of 2P square minus 2P plus 1. So square root of 2P square minus 2P plus 1. That is the answer. Is it all? Now let us move on to the next problem. Look here. This is an interesting problem. Look here. NCC ferret is going at a uniform speed of 9 kmph. So the velocity of that NCC ferret is 9 kmph. Right? Under a mango tree on which a monkey is sitting at a height. See here, this is a tree and there is a monkey sitting on the top of the tree. This is at a height 19.6 meters. At any particular instant, the monkey drops a mango. It is a monkey. It is continuously dropping mangoes from the tree. Okay. So here, a cadet will receive the mango whose distance from the tree at the time of drop. Even the NCC cadets, they are marching at a constant rate. So one particular cadet who is exactly at some particular distance from the tree, he can catch the mango dropped by the monkey. See here, the time taken by the mango to come this point is square root of 2h by g. If a body is dropped from a height h, time of free fall is square root of 2h by g. So it is 2 into 19.6 divided by 9.8. So this is 2 seconds. So the mango dropped by this reaches the ground takes 2 seconds. Now, once such cadet will receive the mango whose distance at the time of drop. So here, if the cadet is at that point, in these 2 seconds, he has to reach exactly the bottom of the tree. So the time taken by the cadet to reach that is 2 seconds and his velocity is 9 kmph. If you convert that into meter per second, it is 2.5 meter per second. You have to multiply that with 5 by 18. So S is equal to V into T. 2.5 into 2, that is 5 meters. If the cadet is at a distance 5 meters from the tree, then he can catch the mango dropped by the monkey. Is it clear? So actually there is a tree here and on the top of the tree a monkey is sitting and it is continuously dropping mangoes. So by the time taken by the mango dropped by it to reach the ground is 2 seconds using this formula. So exactly at the instant of dropping, a cadet is here. So in those 2 seconds, if he reaches that point, then he can comfortably catch the mango. That's what is asked in the problem. Now go to the next problem, 36th problem. A small toy starts moving from the position of rest under constant acceleration. Starts from rest with constant acceleration. Travels a distance 10 meters in t seconds. Distance traveled by the toy in the next t seconds will be. Look here. In case of a body starting from rest, moving with uniform acceleration, displacement in the nth second, u plus a by 2 into 2n minus 1. So a is constant, Sn proportional to 2n minus 1. So what we conclude from that is range displacements in successive equal time intervals. In the first interval, 2 minus 1, 1. In the second equal interval, 2 twos are 4 minus 1, 3. In the third equal interval, 2 threes are 6 minus 1, 5, and so on. So, ratio in case of a body starting from rest, moving with uniform acceleration, ratio displacements in successive equal time intervals is 1 is to 3 is to 5 is to 7, so on. So, let us apply this. That is straight away we can answer. It travels a distance 10 meters in t seconds. Distance traveled by the ball by the toy in the next t seconds. In the first t seconds, it traveled a distance 10 meters. In the next 2 seconds, it travels a distance 3 times the initial. That is 30 meters is the correct answer. Is it okay? Because ratio of displacements in successive equal time intervals is 1 is to 3 is to 5 and so on. Okay. Now, let's move on to the next problem. 37th problem. Engine of a train moving with uniform acceleration passes a signal post. This is a signal post with a velocity u. And the last compartment with a velocity v. So by the time, so let this velocity be v. Velocity with which the middle point of the train. So velocity at that point. In case of a body moving with uniform acceleration, if u is the initial velocity, v is the final velocity, we know velocity at the midpoint is root of u square plus v square by 2, isn't it? So if you have that in mind, straight away it is option 1. And actually we have derived that while dealing with the synopsis. It is very simple. This is yes, this is yes, A is constant. And you need to find out velocity at this point. Let us take this as x. As v square minus u square is equal to 2as here. Here, acceleration is same, s is also same. So, here x square minus u square is equal to, if you consider this part of the journey, v square minus x square, if you bring this to this side, 2x square is equal to u square plus v square. X square is u square plus v square by 2. X is square root of u square plus v square by 2. So velocity at the midpoint of the journey is square root of u square plus v square by 2. So we are considering that concept here. See, this is the post. The starting point of the engine crosses the post with a velocity u and crosses with a velocity v. It is uniformly getting accelerated. So velocity with which the midpoint of the train crosses that post, very obviously velocity at the midpoint, the first option is true. Now let us move on to the next problem, 38th problem. Look here. A helicopter, read the problem carefully. A helicopter rises from rest on the ground vertically up. So helicopter is rising vertically up, starting from rest with uniform acceleration, which is equal to g. A foot packet is dropped from it when it is at a height h. What is the height taken? See here. Suppose this is the ground. Suppose when it is at this point, if a foot packet is released from the helicopter, then already by that time the helicopter might have attained some velocity. So it just becomes equal to vertical projection from the top of a tower. So let this be the height h and this is by the time the food packet is released from the helicopter, if helicopter velocity is u, then the food packet moves up and then comes to the ground. So minus h is equal to u capital T minus half gt square, where t is the time taken by the food packet to reach the ground. So height of the helicopter is known, but we do not know the velocity of the helicopter at the instant the food packet is released. For that, consider this. Suppose on reaching the height h, what is its velocity? So from the relation v square minus u square is 2as, v square is equal to 2gh, from which v is equal to square root of 2gh. So the velocity of the helicopter at the instant the food packet is released is root 2gh. So in this formula, u is equal to root 2gh. So let us substitute that over here. Minus h is equal to root 2gh t minus half gt square. We need to find t here. So let us bring that to this side. Half gt square minus root 2gh into t minus h is equal to 0. This is a quadratic equation in t. So t is equal to minus b, that is minus of minus plus square root of 2gh plus the root of b square 2gh minus 4ac. 4, a is g by 2, which is minus h. Minus of minus becomes plus. So 2 divided by 2, a is g by 2. 2 and 2 gets cancelled. So this is root 2gh, that is 2 plus 2, root 4gh by g. So look here. Okay. Now t is equal to root gh by g. We are taking that root gh as common here. It is root 2 plus root 4 is 2. So this gets cancelled root g times. So t is equal to root of h by g. Root 2 is 1.414 plus 2, 3.414. So our answer is t is equal to root h by g, 3.414. So if you look at this, this is the correct option for that. This is the correct option for that. We got 3.414 root h by g. That is exactly the correct answer for that problem. Understood? See? Okay. So it is simply when a body is projected vertically up from the top of a tower with a velocity u, if it reaches the ground in time t, minus h is equal to ut minus half dt square. That is the hint for that problem. Okay. Now let's move on to the next problem. A ball is released from a height h. If T1 and T2 be the times required to complete first half and second half of the distance, choose the correct relation between T1 and T2. So, ball is released. Released implies U is equal to 0, A is uniform, that is G. Okay, then S is equal to ut plus half at square. So half gt square, or s proportional to t square, or t proportional to root s. Straight away we can use that concept for the problem. Look here. Ball is dropped from the point H and time taken for the first half of the journey is T1. Time taken for the next half of the journey is T2. What is the total time taken? It is T1 plus T2. If you consider this as a starting point, this is yes, and this entire distance is 2s. So T1 by T2. T1 by the total time is T1 plus T2. That is, during time T1 distance is S, during time T1 plus T2 distance is 2s. Because half the distance is covered in time T1, the remaining half is covered in time T2. So the total time taken is that. So, and T proportional to root S. So here root 2 T1 is equal to T1 plus T2. Root 2 T1 minus T1 is equal to T2 implies T2 is equal to, if you take that T1 as a common factor, root 2 minus 1. T2 is equal to root 2 minus 1 T1. That is the answer. Is it okay? And the last problem for this session. Okay, next problem. Look into that 40th problem. Meanwhile, read the problem. Okay. So here, let us read that 40th problem. A ball is thrown vertically up with certain velocity. Okay, it is thrown vertically up with certain velocity so that it reaches a maximum height h. Find the ratio of times at which it is at a height h by 3. Look here. Suppose body moves up and then it comes back to the ground. Find the ratio of times at which it is at a height h by 3 while going up and while going down. This is h by 3. So this will be 2h by 3. So this time is T1 and again the total time this time is T2. We are asked to find the ratio of times while going up and coming down respectively. So vary T1 by T2. So I'll tell you a very brilliant method for this. Look here. Suppose if you consider the free fall, the total time is T here. So what is the time taken to fall through? 1/3. This is 1/3. So this distance becomes 2/3 of the total distance. See, in the previous problem we have seen, in case of freely falling body, S is half gt square from which t proportional to root s. So follow me very carefully. So if total time of free fall is t, the time for this distance, if you take it as t1, so that will be root 2 by 3 times t. This is root 2 by 3 times. So let us take that as some x. So this time will be equal to the total time minus root 2 by 3 times t. Now we know time of ascent is equal to time of descent. If you project a body vertically up, if this time taken is t1, this time taken will also be equal to t. Here, actually, this is the total t minus this time is t1. So, t1 is equal to t plus root 2 by 3 t. Similarly, t2. T2 is the total time taken up to this point. That is, T2 is equal to time of ascent is t plus this time is root 2 by 3 t. You just has to find the ratio T1 by T2 we can take that 3 as a common factor outside and cancel 1 minus root 2 by 3 by 1 plus root 2 by 3. This is root 3 minus root 2 by root 3 plus root 2. That is the problem. So option 2 is the right choice. Okay. So I'll stop here for today. So for sure, every day. See, all the students who are appearing JEE main phase 1 in the month of January, this period is so important. Every day you have to do at least 25 problems physics and 25 problems from mathematics, and you have to read the chemistry textbook thoroughly well, and you have to practice at least 25 problems. And definitely you have to complete all the PYQs starting from 2019 to 2025 at least, because so many models are getting repeated. So to score 99 percentile, the secret behind is first read the concept, memorize the formula, learn application through practice, and then take practice examinations without fail that are being conducted by your college or organization. Thank you and bye bye.